In this video, we have the integral of x over x squared minus 4x plus 8. Now, I want to point out to you that you can write this integral, you can complete the square, pretty straightforward here, and write it this way. That's the same thing. X minus 2 quantity squared is x squared minus 4x plus 4, and then this 4 gives you 8. So you could use a trig substitution here, say tangent of theta. You could use this as your u here. Tangent of theta is x minus 2, opposite over adjacent. This would be a 2 here. And you could use a standard trigonometric substitution, and it'll work out. I did it that way the first time, and then decided to play around with it, and this is what I did here. So it's just the integral. I'm just going to leave the denominator the way it is. X squared minus 4x plus 8. Got x on top, I'm going to put 2x, but I'm going to multiply the outside by the constant 1/2. So I haven't changed the integral, just looks different. 1/2 times 2x is still x, so that's the same. And then on top of that, I'm going to add a minus 4 and a plus 4. So in other words, I'm adding 0. So nothing has changed. And I got the dx right here. And then we're going to break this up into two integrals. So I got the 1/2 still out in front. So I'm going to put the 2x minus 4 together. And that's going to be over the denominator, x squared minus 4x plus 8. Then I got the dx here. And then the other integral will be again plus, again, we're just taking this, breaking it into two integrals. Still got the 1/2 out here. And then this time it'll be the 4. And then I'm going to rewrite the denominator the way I did earlier. So instead of writing x squared minus 4x plus 8, I'm going to write this as x minus 2 quantity squared plus 4. And you get the dx over here. Now these are easy to integrate now, because notice here for this one, x squared minus 4x plus 8, the derivative of this denominator here is 2x minus 4. Exactly what I have up there. So if I let u equal to x squared minus 4x, then du will be this right there. So I hope you can see this, that the integral for that first one is going to be 1/2. So we're going to have a 1/2 then, and it's going to be the ln of the absolute value of the denominator. But x squared minus 4x plus 8 is a parabola that stays above the x-axis. So it's never negative. So I don't need absolute values. You can put them in there if you want, but in this case it's not necessary. So this will be x squared minus 4x. So the integral for this one right here, using a standard U-substitution, again, this would be your u. Du would be 2x minus 4 dx, and this becomes du over u, where u is this right here. Now for the second one here, this is plus. This is where we're going to use the inverse tangent. It's in that form. This form, we've used this formula in several videos. If you have du over a squared plus u squared du, anything you can write in this form. You can have a constant here and just take it outside the integral there. So it's integral of du. I only need one du though. So du over a squared plus u squared. The value of this integral, anything in that form, is 1 over a. A is a constant here. Notice it's a squared there. And then you have tangent inverse. So it's 1 over a arctangent, or tangent inverse, of whatever u is over a, plus the constant of integration. Now, in the example over here, I'm looking at this separately. This would be my u, and the constant over here, that's your a squared. Doesn't matter what order they are here. But the constant represents the a. So this would be, say, 2 squared here. 2 squared, so a is 2. A is equal to 2. So I bring this out here, factor it out. So it becomes 4 over 2, which is 2. And then over here, by the formula, that coefficient is divided by a. In our case, like I said, a is 2. So 2 into 2 is 1. So this is going to give me then arctan, or tangent inverse, of u over a. So in our case, the u is x minus 2. So again, final answer here is 1/2 natural log. Again, absolute values are not needed here. X squared minus 4x plus 8 plus arctangent of x minus 2 over 2 plus the constant of integration. And this is your final answer. Thanks for watching. We'll see you next time.